Alright, we're going to start chapter 6 today, and I'm going to break this video into a couple of parts for this because this first unit is kind of long and lengthy. So this first part here, it says the Polygon angle sum theorem. And actually angle sum theorems, it's plural. There's two theorems that we're going to look at. First of all, what's a polygon? And a polygon is a closed figure. You're going to see a figure that has corners to it. A circle is not a polygon. It has to have corners. Now, polygons can be made up of a different number of sides. We've just got done with Chapter 4 and Chapter 5 where we focused largely on triangles. Triangles are one type of polygon, a three-sided figure. There are 4 sides, 5 sides, 6 sides. We're going to look at that in this unit. Okay, a polygon is named by naming its vertices. So you recall from Chapter 4, when we were naming triangles, we used the 3 corners of the triangle. The same is true for any figure. You're going to start with one corner, and it doesn't matter what corner you start with. There's a variety of ways to name different figures. So this says this figure could be called D if they start with D and they move around the figure in a clockwise manner in this way. So you'd say D, B, A, C, E. Notice that all of the letters are capitalized and they're in order as you move around the figure. Now you do not have to go clockwise. You could go the other way if you wanted to. Okay, and I could start with a different letter. I could start with A. If I start with this corner and A, and I could move around counterclockwise around the figure. It does not matter, but I do have to go in order. I cannot skip a letter. So I would say A, B, D, E, C. Okay, that's true with any figure, triangle, and in this case, this is a 5-sided figure. Start with any corner you choose, and you can go clockwise around the figure or counterclockwise around the figure, but you do have to go in order and include all of the corners. Okay, that's how we name different figures, and we use capital letters again. Okay, the word poly, as in polygon, poly means many. So a polygon is just a figure with many sides. We name specific polygons according to their number of sides. So right here, we all know that if a polygon has 3 sides, we call it a triangle because the prefix tri means 3. So triangles we're familiar with. If it has 4 sides, it's called a quadrilateral. Okay, quad means 4. If you have a quad cab truck, you have seats for 4 people. So quad means 4. A quadrilateral has 4 sides. A 5-sided figure is a pentagon. Penta means 5. So a 5-sided figure is a pentagon. 6-sided figure is a hexagon. 7-sided figure is a heptagon. An 8-sided figure is an octagon. Now, some of these, 10-sided figure, a decagon we're familiar with, but I would say the ones we're not familiar with are the 9, the 11, and the 12-sided figure. Those are things we don't see very often, so make sure you read through those names. A 9-sided figure is a nonagon. An 11-sided figure is an undecagon, and a 12-sided figure is a dodecagon. Okay, so familiarize yourself with those because you might see those words in a problem and you need to know how many sides we're talking about. Okay, and then over here it says for anything that's greater than 12 sides. So you notice this list only goes down to 12. When we get to a 13-sided figure and above, we just use the number in the name. So a 13gon would have 13 sides. A 27gon would have 27 sides. Okay? Notice that all of these starting with 5 on down, they end with a gon, G-O-N. Okay, so that's how we do anything above 12 sides. Okay, so be aware of that. A couple of other vocabulary features that you're going to need and be expected to know is, first of all, what a regular polygon is. A figure is a regular polygon if all of its sides are congruent and all of its angles are congruent. So you can see in this figure right here, you can see the sides all have the same number of tick marks. That means all of the sides are congruent. And all the angle measures have the same number of arc marks. That means all the angle measures are equal. In that case, that's considered an irregular polygon. Okay, in this case, it has 1, 2, 3, 4, 5, 6 sides. A 6-sided figure is a hexagon. So a regular hexagon has the same length of sides and the same angle measures. Okay, this would be considered an irregular figure. Okay, you can see some sides are congruent. 4 of the sides are congruent, but these 2 sides have 2 tick marks, making them congruent to each other, but not congruent to the other side. So that would be irregular. The other thing, the polygon is considered convex if all of its diagonals are completely contained within the figure. So we draw a diagonal by choosing a corner, and I can draw diagonals through this figure. Those are 3 diagonals. You just have to skip the next consecutive vertex. But these would be 3 diagonals. They're all inside the figure. That makes it convex. This is also a convex figure because any diagonal I can draw here is going to be completely inside the figure. Okay, you can see some examples here. If it's not convex, then we call it concave. That's a new vocabulary word. So here, when I go to draw a diagonal with this particular polygon, if I go from this corner to I skip a corner and I go there, that's a diagonal still. However, it's outside of the figure itself, so that makes this a concave. One thing that I think of when I think of those vocabulary words is concave. Kind of, you get that idea of it caves in. So if you have any of the corners that actually go in towards the inside of the figure, that's going to be a concave figure versus convex, where all of the corners are outside. Okay, now what you're going to do is you're going to figure out what all of the angles added up inside the figure are going to equal. And one thing that we've already learned first semester was that when we have a triangle, what do all 3 angle measures add up to? Okay, well, you're right. All 3 angle measures of a triangle add up to 180 degrees. We learned that early on. So the way that we calculate figures that have more sides is we figure out how many triangles fit inside the figure. So if I have a quadrilateral here, a 4-sided figure, I can pick one corner and I can draw one diagonal. And that one diagonal creates 2 triangles. And since there's 2 triangles and each triangle has 180 degrees in it, I would take 180 times 2, and that would mean that a quadrilateral is going to have 360 degrees. That means the 4 angles of that quadrilateral are going to add up to 360. Okay? When I look at a pentagon, so this is a 5-sided figure, I'm going to pick out one corner, and I'm going to see how many diagonals I can draw. For a pentagon, we can draw 2 diagonals from the same vertex, but that creates 1, 2, 3 triangles. So I would be taking 180 degrees times 3, and that's 540 degrees. So every pentagon, every 5-sided figure, the sum of the interior angles will be 540 degrees. Okay, and that's a pattern. You're actually seeing a pattern here. Okay, it says how many triangles are formed by drawing diagonals from a vertex in a convex octagon. What would an octagon look like? Okay, well, we've got a formula down here at the bottom. When you are trying to calculate the total number of interior angle sum, so you're trying to add up the inside angles, interior means inside, what we do is we take the number of sides of the figure, how many sides is in, we subtract 2 because that tells us how many triangles we can get inside, and we take that times 180. So if I were calculating the octagon, oct means 8, octa means 8, so if I were going to plug it into this formula, I'd take 180 degrees times, I'd take 8 sides minus 2. 8 sides minus 2 is 6. If I took 180 degrees times 6, that is equal to, I believe, 1,080. So if I added up the 8 angles inside the octagon, I get 1,080 degrees. It's always the number of sides in the figure. You subtract 2 first. That's how many triangles you could draw in the interior, and you take that times 180. Okay, so you're going to be taking a figure like this, and you're going to be solving it for x, or you're going to be just simply calculating how many degrees that figure has in it. So the first thing we have to know is these are all interior, they're all inside angles, so I'm going to use that formula. How many sides do I have? Okay, that's 5 sides. Okay, so if I have 5 sides, how many triangles would I have inside that figure? You always take the number of sides and you subtract 2. That means I can get 3 triangles. And that's the number that I take times 180. 180 times 3. So 540 degrees is what that total is. Now, they want you to find x. We know that they're all going to add up to 540. To solve for x, we have to add the 5 together. So I would take 112 plus 108 plus 7x minus 7 plus 4x minus 23 plus, the last one is 3x plus 14. And I would add all of those together, and I would set it equal to 540. Okay, I'm running out of room here. So we would have to combine our like terms. So 7x plus 3x, that's 10x, plus 4. That's going to be a total of 14x. I'd have to take 112 plus 108, that's 220. 220 minus 7 is 213. 213 minus 23 would be 190, and that would be 190 plus, that would be plus 204, I believe. Go ahead and check my math there. Yep, so I get 204, and then I'm just going to solve that equation. So I'm going to subtract 204 from both sides. I get 14x equals 336. Divide by 14. So I get x equals 24. So I've found the value of x. And that's how you're going to complete those problems. Okay, we've got a little cabinet unit here that's going to be used probably in a corner of a house. It says Jen is building a corner cabinet to fit in a rectangular room. Okay, if she builds it with the angles shown, how can she determine whether the cabinet will fit? Okay, so we've got a 1, 2, 3, 4, 5-sided figure here. Okay, this corner right here needs to be, we got to figure out how many degrees that's going to be. If it's going to fit into the corner, how many degrees would it need to be? Okay, probably 90 degrees, right? So let's see what it turns out to be. I know the other 4 angle measures, so I'd say 90 plus 135 plus 135 plus 90 plus x, and it's all got to equal 540. Okay, so if we add the parts together, 135 and 135 is 270 plus 90 and 90 is 180. If I add these two together, I get 460 plus x equals 540. We subtract 460 from both sides. We get x equals 80 degrees. Okay, so is that going to fit into the corner? I'm going to say no. It's not. Okay, it's in a rectangular room, so that would have to be a 90-degree angle, and it's not. It's only going to be an 80-degree angle for that to work. Okay, so that's all we're going to do. We're going to look at the first part of that 6-1 worksheet where we're finding out the interior angle measures. Go ahead and get started on that worksheet.